Okay, so next example wants us to evaluate the following trigonometric expressions without using a calculator and using SOHCAHTOA. So, evaluate. Remember, I've told you guys this means give me a value, right? So you're not giving me an angle, you're actually giving me a ratio of two sides because it's the cosine of 60 degrees. So what this is going to do is combine reference angles, which we just did and we're pretty straightforward, and SOHCAHTOA together, okay? So what I'm going to do real quick is give you guys a post-it, and we're going to make some steps. So step one is always to draw the angle. Okay, so you're going to write this on a post-it note and just leave it on here. Step two, what you're going to do is make a triangle with the x-axis. That's super important that it's the x-axis. So remember we said you go up or down to make this triangle. So that's a line up or down. Step three, label your reference angle. Okay, step four. These are all rigged. If you can't use a calculator, these are rigged to be special triangles. So next thing you're going to do is label your special triangle. And step five is going to be SOHCAHTOA. And let's squeeze step six in there. Step six is to simplify. Alrighty, so you can pause the video, get those all copied down. These are your steps. We can actually put a title on this: Evaluating Trig Functions. And this can just stay on this set of note sheet, or stay on this set of notes. Alright, so I'm going to kind of keep this right here so we can reference it as we do this. First thing, draw the angle. 60 degrees, alright, is about right there. Next step is to make a triangle with the x-axis. So in this case, the line comes down to the x-axis. Label your reference angle. Well, what is this angle? It's a 60-degree angle. How do I know? Because that's the angle between the x-axis and where 60 degrees is. So they just happen to be the same because they're in quadrant 1. Label your special triangle. Okay, opposite 60 degrees is always the square root of 3 over 2. The hypotenuse or radius is always 1. And then the opposite, if this is a 60-degree angle, then that little guy up there is a 30-degree angle, so this is 1/2. Now, step 4 we've just done. Step 5 is SOHCAHTOA. Well, this is cosine, so that's going to be adjacent over hypotenuse. So if I'm doing adjacent over hypotenuse, the cosine of 60 degrees is equal to adjacent, which is 1/2, divided by the hypotenuse or the radius, which is 1, so that equals 1/2. Okay, there's the value that I was talking about. It's a value of 1/2. Okay, next one, sine of 30 degrees. So I draw my angle. Again, you guys, this is the initial side always, and most of the time we don't draw that. Do you see the angle right there? That's a 30-degree angle. You don't have to draw the initial side. If you want to, you can, but this is called the terminal side. It's just where the angle actually ends up. Drop it down to the x-axis, and in this case it's a down line. And then this is 30-degree reference angle, and then label your special triangle. Okay, cool. Opposite 30 degrees is always 1/2, which means this is root 3 over 2, because that would be a 60-degree angle, and that's 1. So then the sine of 30 degrees is equal to, now the ratio for sine in SOHCAHTOA is opposite over hypotenuse. So this is going to be opposite the 30-degree angle is 1/2, and the hypotenuse is 1. 1/2 divided by 1 is just 1/2, because anything divided by 1 is itself. All right, moving on. Tangent of 45 degrees. So here's the 45-degree angle. Again, initial side if you want, I don't want. 45 degrees cuts that quadrant exactly in half, so do your very best to make sure that you do that too. And these two sides of the triangle should be equal. So label your reference angle, it's a 45-degree angle, and then you're going to label your special triangle. And so opposite 45 degrees is always root 2 over 2. Alrighty, so the tangent of 45 degrees is, SOHCAHTOA, so we have opposite over adjacent. So opposite would be root 2 over 2. Adjacent would be root 2 over 2. And we could copy dot flip this, but I think you guys are pretty intelligent and you know that anything divided by itself just equals 1. So the tangent of 45 degrees equals 1. Ready to move on. All right, we're doing cosine of 210 degrees. So I'm going to stop for just a second and point out to you guys that all of these three problems were in quadrant 1. So the next one, we're not going to be in quadrant 1 anymore. Let's see where we end up. We start here and we go to 210, which is 30 degrees past. Now, I'm not going down. I'm going to be going up to the x-axis right there. And if I went 30 degrees past, that's a 30-degree angle right there. Okay? Still a right triangle as always. Opposite 30 is going to be negative 1/2. Can you figure out why it's going to be negative 1/2? Well, look at the y. You're down in quadrant 3, and anything in quadrant 3 has a negative x coordinate and a negative y coordinate, right? So you can kind of imagine this as a point, like x comma y, and both of those would be negative because in quadrant 3, you're negative. You're on the negative x-axis, and since you're below the x-axis, you're also in negative y. And then the really cool thing is that your hypotenuse is always positive 1. So you never have to worry about that. Just the other two sides of the triangle. Okay, so we're dealing with cosine of 210 degrees, and that's adjacent over hypotenuse. So adjacent to that reference angle right there is negative root 3 over 2, and the hypotenuse is 1. So we get negative root 3 over 2. Man, really love trig. We got SOHCAHTOA, we got special triangles, we got graphing angles, we've got this. Okay, sine of 150 degrees. So we go 90 and then we go 60 past 90 to give us 150. So now we need to find our reference angle. So you heard me say we just went 60 past, so that just must mean that that's 30 degrees, all right? Opposite 30 degrees is always 1/2. The hypotenuse is always 1. And this guy is actually going to be negative 3 over 2 because you're in the negative x-axis. So anything over here is positive x-axis. Anything over here is negative. For the heights of our triangle, anything up here is positive and anything below the x-axis is negative. All right, sine of 150. Sine is going to be opposite over hypotenuse. So opposite the 30-degree angle is 1/2 over 1, and 1/2 divided by 1 is 1/2. All right, tangent of 315 degrees. So tangent of 315 degrees is right here. If you're wondering how I'm graphing that so quickly, like I know this is 270 and that's 360, and I also know these problems are rigged because it says without a calculator. So if you can't do it with a calculator, anything that ends in a 5 has to be a 45-degree angle. So we are going to connect this to the x-axis, and there is our 45-degree reference angle. Opposite 45 in this particular triangle is negative root 2 over 2 because that side is below the x-axis. This one's not negative though because it's the x-axis, so that's positive, and that's 1. So then we get the tangent of 315 degrees. Tangent is opposite over adjacent, so this is opposite negative root 2 over 2 over adjacent, which is root 2 over 2, which equals negative 1. Okay, so there's that one. Let's flip it over and just finish up these last couple ones. I'm going to bring our post-it note over just in case we have questions, and we'll go from there. So we have sine of 240 degrees, so we are going to draw the angle. 240 degrees is like down here. So it's going to be 60 degrees past 180. There's my right triangle, so that's 60 degrees. So then that's going to be opposite, that will be negative root 3 over 2. Up here will be negative 1/2, and this will be 1. And again, this is negative x and negative y. And then let's do sine. So sine of 240 degrees, a sine is opposite over hypotenuse. So we have negative root 3 over 2 all over 1, which is negative root 3 over 2. This is the benefit of being on the unit circle, is that everything has a radius of 1. So when you're doing sine and cosine, you just end up getting your x-coordinate. We're not always on the unit circle, so you can't just make a formula where the hypotenuse is always 1. But without a calculator, we're on the unit circle. So 300 degrees, 30 degrees past the 270 because these guys are rigged. I'm going to draw a line up to the x-axis. That means this is 60 degrees right there because if that little sliver was 30 degrees past, so that has to be 60. So this is negative root 3 over 2, 1/2 and 1. Ooh, this one's going to get a little bit fun. Tangent of 300 degrees is opposite over adjacent. So I'm going to move my sticker out of the way here. Opposite is negative root 3 over 2. Over adjacent, which is 1/2. So this is where we have a fraction and a fraction. You can only have one fraction bar in math. So the way we do this one is we copy the first one, we dot the fraction bar, and we flip the last one. And then the 2's cancel, and we get negative root 3 over 1, which is negative root 3. Okay? So just a little bit of a copy dot flip. You might want to write that on there so you know what you did. Copy dot flip. This is like the ownership part, like just making sure you take little notes so you can remind yourself. 45 degrees. So like both of these, I already know both of these are 45-degree angles because it says you can't do it with a calculator, so no calculators allowed, and they both end in 5. So 405. This is 360. And then 45 more puts me at that angle right there. So this is a 45-degree reference angle. So that's root 2 over 2, that's root 2 over 2, and that's 1. We're doing the cosine of 405 degrees. Cosine is adjacent over hypotenuse. So it's going to be root 2 over 2 over 1, which is root 2 over 2. Alright, sine of 495, 360, okay, 36, 45. This right here would be 54, so this is where 495 is. We drop it down to the x-axis. This is root 2 over 2. Let's get that in the appropriate color pen. Negative root 2 over 2 because I'm in the negative x-axis, and 1. Sine of 495 degrees is going to be opposite over hypotenuse, which is root 2 over 2 over 1, which is root 2 over 2, which gives you that. So I'll show you guys something real quick in your calculator before we look at the rest of the calculator problems. If I'm in mode and I'm in degrees and I go sine of 495 degrees, I get this decimal right here, and you're like, what? We got root 2 over 2. Why is it that decimal? Well, watch. If I do second square root of 2 divided by 2, so that's this root 2 over 2 right here, and hit enter, there we go. It's the same thing. So it's just in decimal form rather than in exact form. So these are approximations versus this is the exact value because there's no rounding going on, okay? Your calculator has to round. Square root 2 over 2 is an irrational number. It's kind of like pi. It keeps going on forever and there's no pattern, okay? All right. Next, we're going to use our calculator to evaluate these angles to the thousandths. None of these are special triangle ratios. They're not going to give us 30, 60, 90 reference angles. So we literally just type them in our calculator. Sine of 71 degrees. So we're going to write this as 0.946. Next one. Cosine of negative 213 degrees. Make sure you use the negative button instead of the minus button when you do this. So we get negative 0.839. We're going to do the tangent of 537 degrees, which equals negative 0.052. And then finally the sine of negative 353 degrees. And we get 1.22. So not 1.22, 0.122. Alrighty, and that's it. Yay!